Welcome to the next video. We've come to an end with BIMDAS. We've been looking at these indices, so that was our extra piece of information for second year. Now we're going to just finish off one thing to do with this BIMDAS in this video, and then we're going to move on to something else in Numbers Paint 1000 Words, Part 2. So I want to have a look at the answers that you'll get with BIMDAS. So if you had an answer of 324 or 3240 or whatever, I want to have a look at the numbers here. And this video is important because it's something that people make some mistakes on and lose marks on and forget some of the key parts to it. So in first year we looked at rounding numbers, and we also looked at something that we called significant figures. So it might be worth going back on your first year information and reminding yourself, how did we round numbers and how did we find significant figures to 2 significant figures or to 3 significant figures. So what we're going to do now is going to be related to those 2 things. And we're going to look at 2 things in second year. So that will make 4 parts for first and second year. Now this in particular is something that a lot of people make mistakes on and lose marks in, and it's something that should be an area where we can pick up lots of marks rather than lose the marks. So we'll start with this first bit just here, and we've been using indices, so it's going to be related to indices. So let's look at a little example. I'm going to imagine that we did a BIMDAS question and we worked our way through the steps, and then I've got an answer of 673. Now that's fine, you could leave the answer like that, or you could write it in another way. So this video is going to show you another way to write this. And you might think, well, is this not okay to just do it like this? Why do we need another way? Well, we need another way because if you had a really big number like this, you don't want to have to write a really long number. So this way is really useful if you have big numbers, to kind of shorten down what you have to write. So you might have spotted that this number that I've written down here means something. This is actually the speed of light, how fast light travels. And we can shorten this down instead of having to write down 3 with 8 zeros after it. So let's have a look at our simple example, and we'll try 1 or 2 more. Now when I do this, I'm going to use the indices of 10 to the power of something up here. Okay, so having a look at our example, this is 673.000000, and that goes on for infinity. So the decimal point is here. I want to move the decimal point to here. So I've moved the decimal point 2 places. So that will give me 10 to the power of 2. And 10 to the power of 2 is 100. So if I write down, I now have 6.73 multiplied by 10 to the power of 2. Because if you get this number and multiply by 100, I'll get 673. So this is a new way to write 673. If I put up my speed of light, I could, here's my decimal point, I'm going to move my decimal point 1, 2, 3, 4, 5, 6, 7, 8. I could write 3 by 10 to the power of 8. And that's a faster way than having to write out all of these zeros after it. So we give this a name. So this would be an important word to put into your copy. So we call this scientific notation, because this is really useful in science as well. So scientific notation, or you can also call it standard form. So 2 new words in this video so far. Let's try one more and let's see where we're at with this. I'm going to imagine again that I have done a BIMDAS question and I've ended up with a really big number like this. And this scientific notation is really useful for these big numbers, just to write them a little bit simpler. So I'm going to find my decimal point. That's crucial. And again, that will just be 0, 0, 0 forever. So I'm going to have to move my decimal point to the left. So if I move it to the left, I need to move it 1, 2, 3, 4, 5 places. And I'll end up getting 9.8. And I've had to move it 5 times, so that's 10 to the power of 5. And that's the answer that I get. Now you might wonder, why do I bring it to here? Why don't I bring it to 98.0 or bring it up here? Well, this first number always has to be less than 10. So this always has to be less than 10. This is a rule. That's why I'm always bringing it to between the first two numbers. Okay, so that's an important point to know. You have to make that between 0 and 10. And we give this number a name. We call that the coefficient. You've met that word before. The 10, we give that a name. We call that the base. And the 5, or the power, or the indices, we also can call that the exponent. So when you're writing in scientific notation, you've got 3 names here: the coefficient, the base, and the exponent. And the coefficient is a number between 1 and 10. So that's important to know about the coefficient. It's always a number between 1 and 10. Have a look at these examples and we'll see if these are in scientific notation or not. The first one, I can see that the coefficient is not between 1 and 10, so that is not the correct scientific notation. The next one, 3.4, is between 1 and 10, so that's fine. The next one is not between 1 and 10. The next one is, the next one is, the next one is not. This one is between 1 and 10, and even though they haven't written it in, that's 10 to the power of 1. So that's correct scientific notation. And the next one is not between 1 and 10, the coefficient. So that is not the correct way to write it. So that's an important rule about your coefficients. These need to be between 1 and 10. So let's do a little bit more practice. Let's see if I can fill in column 2 here. So I've got column 1. This is how you might see your answers written in BIMDAS, and we need to change them into the second column, which is scientific notation. So the decimal point is at the end of all of these, all the way along. So in the first one, I'm going to move the decimal point 1 place, so I can just do 5.2 by 10 to the power of 1. I can see that all of my coefficients are between 1 and 10, so it's every single one of them is 5.2, even for the biggest number and the smallest number. If you put the decimal point anywhere else, you wouldn't get a number between 1 and 10. In the second one, I have to move the decimal point 1, 2 places, so that will be 10 to the power of 2. The next one, I have to move the decimal point 1, 2, 3. The next one, 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. So that's the correct scientific notation for all of these numbers. And this is the main skill that I want you to be able to do, to take these numbers and to be able to change them into scientific notation, and the opposite as well. So here's a little table for you to practice. I want you to draw this table out in your copy, and I want you to write in all the answers for each of these. So what is the coefficient, what is the base, and what is the exponent for each of these. So you'll have to either take a screenshot and then copy this into your copy. And then I'm going to give you a little second activity to practice, which is this. And I want you to take all of these numbers and I want you to write them in scientific notation. So I want you to do this under your video heading as well. So these two activities need to be done in your copy before you come into the next lesson. So let's end the video just by summarizing. We have in first and second year we have looked at rounding and significant figures, and now in second year we've just had a little look at scientific notation or standard form. That leaves us for the next video to do one last remaining thing on this. So don't forget to do those questions and keep practicing, and we'll see you in the next lesson. Well done.